Hi, and welcome back to Algebra 1. If you are a face-to-face, hybrid, or virtual learner not on the online campus, you are going to need your note packet and your notebook for today. So please make sure you have both those sitting out in front of you. All right, our goal for today is continue working with our skill of expanding expressions using the distributive property. And one application of that expanding process dealing with area of rectangles. So reminders from yesterday and our expanding. Please remember distributing, right? We're expanding using the distributive property. So the word distribute says that something is going to be taken and handed out to other items. That is exactly what you're doing with your numbers or your values. The outside thing, the outside multiplying number is getting handed out to the inside things that are being added up and subtracted. All right, when you do that, you take that outside item and you share it to the inside things. Once you've done that, you need to look and say, are they like terms? What's left over? If they are, I keep going and I simplify further. If not, I'm stuck in the simplifying process would be complete. Now, here's where things get a little bit confusing. When we're dealing with the distributive property, I could see instructions that say expand. And in my head, I have to go, that means do the distributive property. Expanding is the process of taking that outside thing and sharing it. So in my directions, it might say expand the expression, which in my brain goes distributive property. It might also say simplify the directions. And it might still look like this. And when you have a variable expression you're asked to simplify that looks like this, it still means take that outside thing and distribute it to the items in the inside. So this expanded version is also the simplified version of that expression, so be careful. And then it might say use the distributive property, which also tells us take that outside thing and share it with the inside items. So all three of those for this particular problem would mean the same exact process of I'm taking that outside item and I'm sharing it with the inside item. So just be careful. All right, so in your packet from yesterday, this whole page, try them. Hit pause. I'm going through this entire page and trying the on your own ones. Once I'm done, I'll hit unpause and I'll go through the reveal. Try the best you can on your own first. All right, hopefully you've hit pause, you're back, you're ready to go through things. Please edit as we go. Make sure your answers are good because you don't want to have things in your note packet that are incorrect. So, number one, we should have negative 12u minus 20. Now, yesterday I got this question, Miss Hal, can I have plus negative 20 instead? Yes, it's just more basic, more simplified to just leave it as a subtract. But adding the opposite or doing keep change here would be the same exact result. So wherever I have subtraction in my answers, you could have add and then behind it a negative. It's just less simplified version of it. Number two is negative 32 minus 128 times n. Again, I could have plus negative there. All right, number three, negative 5 times w minus 35. Number four, 2x squared. Yesterday we talked quite a bit about this, getting this x squared, and I think we're doing an okay job with that part. But please don't forget, we took x, it was on the outside, and we shared it to everything. So it's going to show up in everything. There's still a bunch of people forgetting it in this term, so be careful. Number five, a negative 18u minus 30un. Back here, I could have the u behind the n, right, and have n u, but they're both still there. There are two variables being multiplied. So nu or un, either one, but they both need to be present in that term. Now, these two things are not like terms. One just has a u, the other one has a u with an n, so we can't continue on and simplify any further than that. And then number six, 54 times t minus 27. Number seven, negative k or negative 1 times k would be the same thing there, plus a 9. Number 8, 16 times m plus a 6 times g. Number 9, 9 times s squared. Again, we're doing a really good job here of getting our s squared. And then a bunch of us are still forgetting that we took s on the outside and we shared it to both things, not just that first time. So it's got to be in that second term also of minus 6s. All right, number 10, we should have a negative 8 times m plus a 4 times k plus a 6. Number 11, a 5 times p plus a 4 times r plus 2. Number 12, a negative 64w minus 12 times q plus a 4 times m minus a 44. And number 13, a 30y plus 10w minus 20r plus 5g. All right, hopefully at this point we're at the place where we understand what expanding using the distributive property in that process. We're going to look at an application dealing with looking for equivalent expressions and dealing with shapes. So in our packet, your next problem looks like this. It asks you to identify the expression that's not equal to or equivalent to the other options. All right, so we're given 4 different expressions here, and we're asked to compare them to find the one that sort of doesn't belong in the list because it doesn't match. The way to look to see if things match is always to put them in their simplified versions. So some of these are already in their simplified versions and others are not. We want to get them all to be simplified before we say which one doesn't belong in the list. So 4 times 6x plus 8 is option A. 24x plus 8 would be option B. Option C, 24x plus 32. And D is a negative 2 times negative 12x minus 16. All right, we want to get them all in their simplified version. So remember for these, since they're variable expressions, the simplified version is the expanded version using the distributive property. So up here, this one's in the factored version. What's called the factored version, where there's 2 things being multiplied still. So we want to take it and expand it to get it to its simplified version. So 4 times 6x and 4 times positive 8. So 4 times 6x would give us a 24x. And a 4 times positive 8 would be a positive 32. All right, that's option 1. All right, B is already in its simplified version. There aren't like terms. There's nothing we can put together here. That one's done. All right, same thing here. This one's already in its expanded version. It's done. All right, down here, we want to expand it to get it to its simplified version. A negative times a negative here will give us a positive 24x. And same thing here, a negative times a negative will give us a positive 32. All right, now that we're in all simplified version, we're looking for the thing that doesn't have matching terms. The order that the terms are in doesn't matter. It's just, do they have the same exact terms? So this one has a 24x, this one has a 24x, this one has a 24x, this one has a 24x. So right now they look like they all match. Even if the 24x was listed second in the problem, that's fine. We're just looking for ones that have matching terms. All right, this is a positive 32, a positive 32, a positive 32, and this one is a positive 8. So letter B in this case would be the one that's not equivalent to the other 2. All right, hit pause. You try the other 2. Get your simplified versions and find the one that doesn't belong. All right, let's go through these. Number 2 and number 3. For number 2, D is the one that does not match. It's the one that doesn't belong. These all have a positive 32 and a negative 16m. Positive 32, a negative 16m. Positive 32, negative 16m. This is a negative 32 and a positive 16m. That's the one that doesn't belong. And then number 3, it's the one that does not match because all the others have a positive 4 and this one has a negative 4, a subtract 4, so be careful. All right, so last application for today. Can we simplify an expression for the area of a rectangle when we're given variable expressions for the measurements of the lengths and the widths? So the thing we have to remember for area of a rectangle is your formula for finding the area or the square pieces that fit on the inside. We take the long side called the length and multiply it by the short side called the width. This length piece is your longer side. The width is your shorter side. So if we're given this picture, and we're going to do some examples here. Again, if I'm learning for face-to-face or hybrid right now, I'm going to need my notebook because this is not my packet. All right, so we want to get the area of that rectangle by calculating the length times width, which means I need a length and I need a width to substitute in its place. Remember, the length is the longer side. The width is the shorter side. Now, here's where things get a little bit tricky. This piece here is our length. It's our longer side. It's made up of 2 terms. So when we take something that's more than one term and we replace it into one variable in the problem. We have to group that whole thing together and show that it's one individual item called the length. So over here, I'm going to group all that together. It's this entire 7p plus 6. So our length is going to be that entire thing, 7p plus 6. All right, our width is the shorter side, which in this case is just 8. All right, length is out, 7p plus 6 is in. Right, this length's out. So 7p plus 6 goes in its place. And then we're going to multiply it by the width, which in this case is 8. And then once we get here, it wants us to write the expression in its simplest version, which would mean I have to expand using the distributive property. Right, so 8 times 7p and 8 times 6 would be our next parts of the process. 8 times 7p would give us a 56p to the first. Bring down your plus. 8 times 6 would give us a 48. Now we're solving for area, so we should have a label here attached. Area, we're counting square pieces on the inside, so we have what are called square units. In this care, square feet would be our label. Good, final, simplified expression to represent the area of that particular rectangle. All right, let's try another. We want to evaluate an expression and write it in its simplest version for the area of that rectangle. Remember, length is our longer side. It's this piece. It's not your bottom, it's your long side. And again, there's two terms here, so we want to say those two become one big thing called the length. So this entire thing, x plus 1, is the length. The width is that shorter piece, which in this case is 3. All right, we're going to replace L and W out, length and width in. All right, so x plus 1 in here, and our 3 in here for the width. All right. Now we want to write it in its simplest version, which would mean to just expand using the distributive property. So 3 times x would give us a 3x, and 3 times 1 would give us a plus 3. Since it's a problem for area, we should have units, and more specifically square units or square labels here, which in this case are square inches. Good, final, simplified expression to represent the area of that rectangle. All right, we want to write a simplified expression to represent the area of our rectangle, length times width, when the length is the longer piece. So this piece is the longer piece. So this entire thing, 5y minus 4 is our length, 5y minus 4. Our width then is that expression 2y. We don't have to put parentheses here because that's one big term, but we could, right? We could say it's this whole thing 2y. All right, L is out. 5y minus 4 goes in its place. W is out. 2y goes in its place. And then we want to write the simplified version, which means we're going to expand using the distributive property. So 2y times 5y would give us a 10y to the second power. And 2y times negative 4 would just give us a negative 8y. These are not like terms, so please don't try to go further. And it's area, so we should have units or labels that are square units, in this case of square miles. Good, final, box it in. All right, one more. This one's a little bit different. And it wants the area of the largest rectangle. So when I give you a picture like this, we're talking about the biggest rectangle, right? This entire one here, ignoring this little black line across the width. And it wants us to find the length times the width of the biggest rectangle and then simplify. All right, so our length is this entire side here. It's not just 8w, it's not just 2. It's both of those added up, right? It's that whole piece, both of those together. All right, so we have to say the length is 8w plus another 2. All right, our width is that shorter piece, which in this case is 15. All right, length times width would be 8w plus 2 times 15. All right, we want to simplify, so expand using our distributive property. 15 times 8w and 15 times 2. 15 times 8w would give us 120w plus 15 times 2 would give us a 30. Those are not like terms, and we should have square inches as our label. All right, I hope that helps you for today. See you guys later.